Class example 3.46. If log base 3 of x is equal to 5 and log base 3 of y is equal to 8, evaluate each of the following expressions. So in this question, we're going to want to expand this expression, and we're going to be looking for any log base 3 of x or log base 3 of y that we can replace with a 5 or an 8. And this makes sense because we want to evaluate this. I don't want any x's and I don't want any y's because those can't be evaluated. So I want to change it to a known value. So let's expand this out and see what we can do. So we're going to expand this out using the first log law. And then we're going to apply the third log law to move our exponents down to the front of the logs. Now we're ready to substitute in the known values. So we're going to look for any log base 3 of x or log base 3 of y to sub in our values. So log base 3 of x here was really 5, and then log base 3 of y here was really 8. And these are all numerical values, so check to see if you can just evaluate that. So in this case, this is just saying 3 to the power of what is 9. So that's just 2. So now perform the calculation, and we get 36. Now, we should be able to verify this numerically. And the way we'll do this, if we take, for example, log base 3 of x, so log base 3 of x is equal to 5. Well, another way of saying that is that 3 to the power of 5 is equal to x. So then we could replace an x with 3 to the power of 5. So that's what we've done here, 3 to the power of 5. And a similar process for y. So 3 to the power of 8 would be equal to y. So 3 to the power of 8. And we can see if you do plug that into your calculator, we still get 36. Okay, let's try the next one. So in this case, we'll rewrite it as multiple logs, remembering that anything in the numerator will be positive, anything in the denominator would be negative. We'll also move the exponents down where we can, so the 1/2 comes down front, and the 3 comes down as the coefficient on that log term. And this log base 3 of 81, well, we can evaluate that. That's saying 3 to the power of something is 81. And we know these values. So this log base 3 of y is really 8. And log base 3 of x, well, that's really 5. And just like we did in the part A example, we can replace the y with 3 to the power of 8. And we can replace the x with 3 to the power of 5. And we still get -7.